Okay. Actually, there was one more in the part C test. This has to do with the binomial probability. This is kind of like the do now we just did today in class. Well, today if you're me making this video, probably a couple of days ago for you. 10c2, 1 6 squared, 5 6 to the 8th. This looks like it has to do with 10 trials because these exponents add to 10, and we're talking about 10 choose 2. And the two things we're choosing would be the 2 times when the 1/6 is successful and the 5/6 times when it is not. This is really a lot like the one we did today. 10c2, 1 6 squared, 5 6 to the 8th is probably part of, if you think about it, 1 6 plus 5 6, the expansion of 1 6 plus 5 6 to the 10th. The first element of that is 10c0 of 1 6 to the 10th power. Actually kind of combines two of the problems we did today. And 10c9, that would be this happening 9 of the 6. 1/6 probability happening 9 of the times. We haven't talked about what that 1/6 represents yet and what this 5/6 represents yet. I'm just trying to go from here back to reality. The next one would be 10c8, I guess. I'll do one more and then I'll skip ahead. 1/6 to the 8th power, 5 6 squared, and skip a few because the one I really care about is this one. This thing is in the middle of all this. 10c2, 1 6 squared, and 5 6 to the 8th. So that's a 6 again to the 8th, and it's not over. It keeps going all the way down to 10c0, 1 6 to the 0, 5 6 to the 10th. So what does this little piece mean in this whole situation? Well, we're talking about rolling a die 10 times, or maybe rolling 2 die 10 times. I guess they said a die. So when you come up with one situation that's going to happen successfully 1/6 of the time and non-successfully 5/6 of the time. Okay, let's say rolling a 1. Let's call the experiment rolling a 1. Makes it a little easier to keep track of. Say you're playing Farkle or something and you really like to get 1s. Let's say that's the experiment, because then I have a 1 in 6 chance of getting that right or succeeding at that, and a 5 out of 6 chance of failing it. So as we go down this little binomial expansion, this would represent the probability, if I calculate this, is the probability that I rolled the 1 all 10 times. This would be the probability that in my 10 rolls, I rolled the 1 9 times and something else once. This whole thing is the probability that I rolled the 1 8 times and something else twice, and on down. When I get to this one, this would be the probability that I rolled the 1 twice, so probability of exactly 2. Out the word 2 so it doesn't look like the number 2. Exactly 2 successful 1s out of the 10 rolls. So that means it had to be 2. It had to be 1 2 of the times, and not 1 the other 8 times. I had to actually fail the other 8, and this is that probability. I don't think we have to actually compute it, but you know what? As long as we're here and there's nothing else I can think to do with this problem, I think I'm going to go ahead and do it. 10c2 is not obvious. 10c2 is 45, I believe. Yeah, 45 times 1 6 squared, that's like 1/36, times 5 6 to the 8th power, good lord. Alright, 5 to the 8th power over 6 to the 8th power. That's just not a pretty fraction, kids. Look at that. Let's leave it and convert to a fraction. 5 6. No, not 5 to the 6. 5 6. Take that to the 8th. Even if I convert to fraction, it's going to be that same. If they give it to me at all, it's going to be that one over that one. Alright, I'm just going to leave that, and I'm going to multiply that by 45 over 36 times 45 over 36. Maybe now I convert to a fraction. I kind of doubt it. Yeah, it's around 29.1%. That's a huge exponent. That's why. So what did I say? 29.07%. Yeah, something like that. So that just means that around 29% of the time, I'll roll exactly 2 ones. I roll a die 10 times, that exactly 2 of them would turn up as a 1. That's a pretty reasonable probability to expect, I think. Okay, now we're on to the form D, and this is where it starts to get really kind of out there in terms of concept-wise, but again, it's only going to strengthen your understanding of this chapter, so it's worth doing. And there's a lot of pages to this, so I don't know if I'm going to go to the trouble of making all the videos for the rest of this or not. We'll see how it's going, and I'll make one tonight, and then if people want more, I'll bow to that request. Okay, consider the total number of non-overlapping triangles in these stages. So I guess I should write the first 4 terms of the sequence. In the first one, this is one triangle. Can't really argue with that. In the second one, non-overlapping triangles. So I can't really count the big one as a triangle because it overlaps with these little ones. So in separate triangles, what they're getting at here is there's 4 there. In the third one, there's 1, 2, 3, 4, 5, 6, 7. Starting to see a pattern yet? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You might not like the way I count them, but you're going to get the same total. Tell whether the sequence is arithmetic or geometric. Well, it appears to be arithmetic. Can I just write this here, save myself some room? It looks like it's an add 3 sort of deal. Right, so now I'm at number 3. See how I did that there? Write an explicit formula. That's one of the ones where you just say, well, a sub n is, and you give the whole spiel. And using n as using n as the thing you're going to compute with. And that is always first term, which is 1, plus n minus 1, and I gotta leave that. I can't really mess with the n minus 1. The only other thing I gotta put in there is the d. And that's 3. If you don't believe that, you can put these in. If n were 1, this would be 1 plus 0 times 3, which is 1. If n were 2, it would be 1 plus 1 times 3, which is 4. If n were 3, the third term, put 1 plus 3 minus 1, which is 2, times 3 is 6, plus 1 is, 7. It seems to be working. Write in a recursive formula. I need some space here for the recursive ones are the, and again, I don't know why they keep asking explicit first and recursive second. It seems like it's way easier to think of recursive first and then explicit second. Anyway, this is the one where it's a sub 1, we have to say what a sub 1 is. We have to say what a sub n is for all the rest of them. Whoops, not less than, greater than. For all the natural numbers as n goes up. Okay. That's the throwaway thing. If you forget this, I am not going to take off a single point. Oh, unless you were going to get 100, and that was like the only thing you missed, then I might be mean. But anyway, a sub n is, take the previous term, take answer, and add 3 to it. A sub n minus 1, minus 1 plus 3 for all the n's above 1. Great. Number 5, find the 10th term. All right. Well, I just said here's an explicit sequence, or explicit definition. I think this is easier to just put 10 in here and find this. This way would require I'd have to actually find all of them 1 through 10. Here I can just jump to a sub 10. A sub 10 is 1 plus 10 minus 1 times 3, which is 27 times 3, which is, gosh, is that 81? No. 10 minus 1 is 9. 9 times 3 is 27. Way ahead of myself. Plus 1 is 28. Glad I stopped myself there. Yeah, the 10th term of the sequence should be 28. Great. B. Assume that the length of each side of the triangle in stage 1 is 1 unit. Repeat part A for the area of the smallest triangle at each stage. Okay. The area of, and I will just keep going back and forth, and you can see all my cool page transitions. All right, we're at the first 4 terms of the sequence this represents. Well, the first one, if the long side is 1, is that what they said? I'm looking for the area of this triangle. Well, that's a lot of geometry. It's 1, area of the smallest triangle. Well, the area of an equilateral triangle of side length 1, well, that length would be 1. If I had to draw a height here, that little thing in there, if you remember from your trig days, well, each one of these is half and half. This is actually square root 3 over 2 for that height. So the area of that thing is, for the first one, the area is 1 times square root of 3 over 2 times a half, which if you do that carefully, if I did that carefully, I get square root of 3 over 4. Yuck. A sub 2, that would be the area of a triangle. Oh, man. Okay, this is 1. Well, now this length of a side here would have to be half. You know what? I could go to the trouble of computing this area with this half thing here. I just know if this triangle now is similar to this one, and I cut the length in half, I'm going to cut the area by a quarter. If you remember that from geometry, I remember that because I'm teaching it right now. So I'm going to cut that area in a quarter. So this is going to be the square root of 3 over 16. I'll just tell you that right now. Great. Again, that little geometric fact, I'm using capital A's here for area. I don't know if that's okay in sequence language, but I'm doing it. Is not something I'm testing you on in Chapter 8 of FST. In Chapter 8 of FST, I'm testing you on, okay, now that once we know what the sequence is, then let's do something about how to try to find the sums of it, or how to try to find the terms and the explicit formulas and that kind of stuff. This geometry piece is just kind of cool icing on the cake, but it's not really what I'm asking for. All right, so if that's half, guess what? This is going to be a quarter. I've cut the lengths in half again, so I'm going to cut from this. I'm going to cut the area to quarter. Or you can actually see, here's the area of this thing. This area is 1/4 of the area of this original one, and this area here is 1/4 of the area of that last one. So it looks like, if you can even think of this as a recursive thing, this area is going down, being 1/4 of itself each time. So there you go. I just kind of give you that in terms of recursive definition right there. So this is another quarter of that one. Square root 3 over 64. How many terms do I need? 4. Okay, so the last one, a sub 4, is supposed to be the square root of 3 over, and I take this by a quarter again, which would be 256. Okay, part 2. Tell whether the sequence is arithmetic or geometric. Well, we've already talked about how it's multiplying each time, so it's geometric. Write an explicit formula, g sub n. It's kind of cool how they got an arithmetic and a geometric in this one nice problem. I do commend them for that. All right, square root of 3 over 4, that's g sub 1, times r, we just talked about, is that to the power of n minus 1. Recursive for that is g sub 1. We have to know what that is. That's square root of 3 over 4. Come on, pen. And g sub n is take the previous term and multiply it by a quarter, or divide it by 4 or something like that. For all n blah 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 blah. Okay, and then part 5. Find the 10th term. G sub 10 here. Of course, I don't know about you, but I'm going straight to explicit for this one. Square root of 3 over 4 times 1/4 to the 9th power. Yee, okay. 1/4 to the 9th power. That's really tiny. Times the square root of 3 over 4. Yeah, you think these would be pretty tiny. I mean, look at these things. They're getting microscopic as we go down the list here. So yeah, look at the 10th one. It's going to be really tiny. If this has a side length 1, that thing's going to be minuscule. Okay, so I had 1/4 to the 9th power times the square root of 3 over 4. Whoops. Okay, that works. Not what I meant to do. Let's do that. Times the square root of 3 and divide it by 4. It's not going to be a rational number, so we're just going to go ahead and decimal. It's 1.65 times 10 to the negative 6th. It's really tiny. And that's square units of area. Okay, great. I might give you another little problem in here before it's time to go. Repeat part B for the perimeter of the smallest triangle at each stage. Okay, great. Same sort of deal. What's the perimeter when the side length is 1? Well, then the perimeter would be 3. It's a little bit easier to do, actually. When the side length is half, the next one, the perimeter would be, well, it would just be half of that, wouldn't it? When I cut the side length in half from that, whoops, 3, the perimeter is going to be half of that again, etc. So it's 3, cut it in half, cut it in half, cut it in half, cut it in half. There's the first 5. Tell whether the sequence is arithmetic or geometric. Again, if I'm going half, 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 that's geometric. I got a minute and a half. I can do this. Explicit formula, g sub n. It's geometric, so I want a g sub n. G sub 1 times ratio, which is half, to the n minus 1. Explicit, the first term is 3. If you're watching this far, you must really love FST, or you're like really into it and you really want to do well on this test. Okay, that's great. This is why I'm doing it, for folks like you. Okay, g sub n is the previous term, answer, so to speak, times half for all n, yada yada yada. I really am sloppy about this now. But you know what? I warned you. I told you I was going to be sloppy about it. So you know what? I don't feel so bad. All right, the 10th term, g sub 10. Again, I'm looking for explicit for that because I don't care about g sub 9. I want to go straight to 10. Equals 3 times half to the... This won't be quite so small. I'm only increasing by half instead of quarters this time. Half to the 9th, which is that times 3, right? Yeah, times 3. That may actually turn into a nice fraction. There's no square roots. It's just really small. 3 over 512. Oh, why not? That's 2 to the 9th. That's my 500 I was talking about earlier. Okay. 3 and 512. If you like percentages, if you want consistency in your life, we could say it's 0.00586. But sure. Yeah, it's going to be way bigger than that last area. Okay. Great. Out of time. We'll see if we need to do another one.